All right, so the first shape that there's so many shapes, but the first one they're showing is what's called a trapezoid. I mean, you've seen this before, and there's some interesting properties of a trapezoid. One is that the bases are parallel.
Okay.
Okay, one set there's one set of parallel sides. So these are called bases, base one, base two. Okay, and the sum of the interior angles is 360. Okay, there's 1, 2, 3, 4 angles. You need to write those in 1, 2, 3, 4 angles, and they all add up to 360. All right. That's kind of it for now. Let's focus on kind of a problem here. So I'll try to do that for each one to kind of like give you a little lead into it for this. So, all right. So it says they give you a trapezoid. Okay. This one happens to have 2 right angles. Okay. So this symbol right here, little box here, that means a right angle. And the angle measure is 90 degrees. Okay. So you can really even write that. You can write 90 and 90 for that. Okay. Now in this problem, it says angle F is 20 more. That means plus. Then 3 times, that's 3 multiplication. Angle F is 20 more, 20 plus 3 times the measure of angle 8. Okay, so like if you knew angle H and you multiplied it by 3 and then added 20, you could get angle F. Does that make sense?
Mm-mm.
Okay, we're just dissecting the words here. This is not geometry, by the way. This is just algebraic equations. So maybe let's spend a little time reviewing how to writing algebraic equations. So let me find a few problems here to kind of show you this. Okay. All right, so here is, now let me see, maybe you need a little bit of, all right, all right, so let's look at an example here. It says 9 more than a number, 9 more than a number. So the word more always means addition. And obviously that the number 9 is there. So 9 more means 9 plus or plus 9, because you can actually do addition in any order. Okay. So you want to sort of associate the word more with plus. It's like a vocabulary thing. All right, let's look at another one here. And notice, I'm sorry, one more thing. Notice they give you the variable y on the right here. All right, so let's look at another one here. 4 less than a number n, 4 less. So the word less means subtraction. Subtraction is a little bit awkward in that you have to start with the letter and then subtract the number, in this case 4.
I don't know how to find out the measure of H.
Well, we're going to like, we've got to be able to convert this to an equation. That's what I'm trying to show you is the possibilities. Do you want us to go back to this?
Maybe.
Okay. So it says 20 more. 20 more means plus 20. I know it's 20 plus, but we write it as plus 20. 3 times means multiplication by 3. So we're going to call angle h x. So 3 times is 3x. So letter F or angle F is 3x plus 20. 20 more, that's the 20 more, 3 times 3x. So this right here is 3x plus 20. Would you like more clarification on that?
No, but how do we find what the actual measure is so we can figure
So
out
that's,
the
yeah, so that's where you got to go back and know that the sum of the interior angles is 360. So you have to add up all of these angles to get to 360. So that's 90 plus 90 plus x plus 3x plus 20 equals 360.
so is every angle 90?
No, just
Oh.
these two. We don't know the other ones. We have to solve for x in this equation. So I'm just gonna grab this equation and bring it down to work on. So our goal is to solve for x. So on the left here, we can combine the numbers. Yeah, there's a 90, a 90, and a 20.
How do we know that one of them is 20?
It's the 20 more than 3 times. Like that whole angle is 20 more than 3 times x. You have to like multiply x by 3 and then add 20. Like that's given in the problem. I'm not making that up.
I thought that was part of angle F. Like you would
It
find
is,
out what
yeah,
angle H is and then times it by 3 and then add 20 to it. I
right. But
don't
we
know
don't
how
know,
that
we don't know
translates to
angle. Sorry,
the other angle being 20
it's not 20. The whole angle is 3x
instead
plus
of
20.
20.
And we don't know the other angle. That's why we're calling it x. Like we're trying to say, if we knew the angle, if we knew this angle, we would multiply it by 3 and add 20 to it. Like as soon as we know the number, whatever it is, okay, we're going to multiply it by 3 and then add 20.
I thought you were saying angle H was 20.
No. So it's. I mean, if you want letters here, that could this is E, G, H, and then all of this is F.
So E is the one going down?
E is the 90-degree angle.
Oh. So
G
that's
is the
not the whole
90-degree
line?
angle. The angle is is what's between the two segments.
Oh, I thought it was the distance.
No, these are angles. I guess I could put that there. Okay, I mean, should we do a different problem? I mean, I can start
No.
with triangles. They're a little easier than this. I mean, we just kind of jumped right into a, you know. Why don't we do something different? Like the triangle stuff I think will be a little easier. Okay. So let me just throw out a much simpler triangle problem. Okay, so here's a triangle. Okay. 45 degrees, 85 degrees, and X degrees. So the sum of the interior angles is 180 in a triangle. So all the angles in the triangle add up to 180.
9 plus 9 plus 9 does?
No, the 45, the 85, and the X.
Wait,
So
I'm looking
45.
at the book. Is this?
No, I'm just making up a problem to
Oh,
kind of just
okay.
start. $45 plus 85 is, could you add those together, and please feel free to use a calculator.
Isn't that 180? No, that would be plus the X too. Uh-oh. My pen doesn't work. I'll just use a calculator. $130.
130 plus X equals 180. So to solve this equation, you have to subtract 130.
From 180, yeah.
Yes,
That's what I'm doing. But let me see. Is it 50?
it is 50. All right, so let's look at another problem. So here's another problem. Let's say the angles are 40 degrees and 58 degrees, and this is angle Y now. Okay. Okay, so same thing. The three angles add up to 180. Just like the last problem here, do you want to try this one?
They're 82.
Yeah, 40 plus 58 plus Y equals 180. Okay, and so yes, Y equals 82 degrees. Okay. Now the other types of there is a special triangle that you might see which has this little box down here, and this little box means 90 degrees. It won't tell you that it's 90 degrees. You'll just have to know. And then this is 38 degrees, and this is X, like this. Okay, so it's very similar. You just add the three angles up, X plus 90 plus 38 equals 180. And you can find the missing angle.
$52.
X is 52. Good. Okay. So here's another right triangle. and say that this is a 31 degrees. Okay, what would the missing angle be?
$59.
Is 59 degrees. Good. Okay, so there's a lot of variations on this problem. Like if the right angle isn't given, they still add up to 180. Okay, and here's a, again, like this adds up to 180. You don't have to be told that it adds to 180. You have to say, okay, I know that it adds up to 180. I'm going to find the missing side.
Is that all you do with them?
Add them up. Okay, so here is so we haven't done this yet, but like if I say 2x plus 4x, can you tell me what that adds up to?
6x.
6x, right? And if I, add a 10 here and say equals, 34, right? Like you have to be able to solve it like what's called a two-step equation like this.
What's the second part?
Well, so the after you combine like terms, you have to undo the addition by 10 and then the division, the multiplication by.
Why? What is it? What
Well,
is
we're
this
going to start
part of
solving some.
geometry?
Well, we're going to we were trying to solve a problem, if you recall, where it had like X's and numbers in it, and we had to be able to work through those. So I was trying to show you how to do some of those.
Is that multiplying polynomials?
No, just adding and subtracting. Like these are just solving, these are called solving multi-step equations.
Oh,
So do you like that? It's kind of like we got to take a sidebar, or like a go to the side here and work on some stuff. I was going to suggest we do some two-step equations or multi-step equations like this to get back where we could solve the other ones. But we can also just go back and look at that equation if you want.
we can do this one.
Okay, so you divide by 6 and x equals 4. So let me give you another one here. So let's just make it
Is it,
much simpler. Let's go ahead.
I was gonna say, is that like I forgot what it's called, where you have to make sure both sides are equal or something.
Well, you want to get the variable by itself. So like here's a new problem. 3x minus 2 equals 7. So we a long time ago talked about order of operations. And this is if you're simplifying. If you're solving, you go the other direction. So you undo addition and subtraction before you, and then you undo multiplication and division and so on.
So you just change the signs?
Well, like you add two, you add two to both sides. Like whatever you do to one side, you have to do the other. And then to undo 3x, you divide by 3. So you undo multiplication with division, you undo addition with subtraction, they're opposites.
And you just keep going down? Do you do anything with the
And
7 at
until
all?
you get x by itself.
Mhm. And you only do it with the middle number?
Well, you do it with your goal is to get the variable by itself. So you have to like undo everything that's keeping the variable from being alone. So let's try another one here. Let's try like 4x plus 1 equals 17, for example. Okay. So to solve this, you have to undo the numbers first that are not being multiplied and divided. Subtract 1, 4x is equal to 16. And then now you can undo the 4 because you can divide by 4.
And so it's that first row?
What do you mean by first, for the one at the equation at the top?
Like it's +1 and then 17, but you do -1 on both of them. Do
Yeah.
you ever flip it and do 17?
No,
Or
you look at the side with the variables. So your focus is always, that's a good question. You always focus on the side with the numbers here. Like that. So let's do, like, for example, let's say on the, it's 3x plus 1 equals 19. Okay. Your focus is on the side with the variable. So you're going to subtract 1, subtract 1. You always look at the side with the variable and then undo the whatever it is, whatever you've got there. Which it's really not that bad. It's you undo addition with subtraction, you undo subtraction with addition, you undo multiplication with division, you undo division with multiplication. Like it's very relatively straightforward. Like in terms of like, it's not like there's an exception. You just undo, you do the opposite of what you see. So this becomes 18 equals 3x, something like that. And then you can divide by 3. So x equals 6.
Okay.
So let me give you a couple here to try on your own. The numbers get a little bit larger. I'm just going out to the internet. So, again, feel free to use, well, and we got some sign stuff too.
So you'd only do one, like
Well,
minus
how do you
one,
undo the +1?
but you would do -1 for underneath both 1 and 80.
Yes, you put -1, -1.
Would that not be 0?
What 0?
1 minus 1?
It is, but you don't write it. You know, +0 doesn't add anything.
Do you always bring down the number with the variable?
You always do, yes.
So what would you do in this case? Because there's no 0.
You
What do
divide
you,
by -9 because that's the number in front of this. Okay, I'm sensing that maybe we should do one-step equations first. I guess I so x equals 9. So okay, so let's
and
look
it's
at another
always
type of,
division on the second row?
no, it depends on what's in front. So the like let's say it's 4x equals 20. Look at the side with x. Okay, this 4 is multiplying the x. So you undo multiplication with division.
Oh, I don't really see that as multiplication when it's like that. I tend to just see it as a variable.
So it's a
I
number.
forgot it was multiplication.
Yeah, it's a number times a variable. So you do that by dividing by 4. So x equals 5, like that. Let's look at another one here. Let's say it's 27 equals 9x. So on the side with the variable, 9 times x, number times variable.
How does that work if there's only one?
You undo multiplication with division. There's a 9 multiplying x, so you undo multiplication with division.
And you always take it from the number with the variable?
Yes, yes. So what is 27 divided by?
3.
It is 3. Good. Okay, so here's another type of equation. What if there's division? Like what if it's x divided by 5 equals 8? Okay. How
You
do you
just do
undo division?
multiplication.
Yes.
I did the 2-step one. I just have to put the the division parts in the calculator.
So yes, you multiply by 5. So x equals 40. X divided by 4 equals, 2. How do you solve something like this?
I don't know.
How do you undo division by 4?
Multiply?
Yes, multiply by 4. What does that become?
Oh, is it 4 times 2?
Yes, yes.
8.
X is 8. Good. Okay, so you've seen the pattern here, like one in one type of problem, let's say it's X over 6 equals 3, and then the other over here, it's like 4x equals 32. And in one case, there's multiplication, so you undo it with division. Excuse me. On the case on the left here, you have division and you undo it with multiplication. So could you solve each of these for me, please?
$18.
X is 18. And how about on the right?
8.
X is 8. Good. So the other types of one-step equations are solved. We've kind of already looked at them, but like, let's say it's X plus 5 equals 11 and 13 equals X minus 4. So on the one on the left, you see addition. So you undo addition with subtraction. Add 4, add 4,
Will you make it a
subtract
negative?
5. You always undo it with the, like, if it's a plus, you subtract. If it's a negative, you add.
Oh no, this is. What's the difference between this and the one we just did? I can't tell.
Let's go back and look. See, there's division, and here there's multiplication. All right, so the idea is, again, like if you have addition, you undo it with subtraction. If you have subtraction, you undo it with addition.
I guess because the X is separated from it. I was
Yes.
just wondering
The-
why there was
okay.
only
Yeah.
there
Sorry.
was 2 rows in this one and only 1 in the other one.
So yeah, like you undo whatever you see here, with the other one. Like in yeah, it's separated by the operator. So like there's no operator for multiplication, like it's just squeezed together. The fraction bar is division. The plus is obviously plus and the minus is minus. And it's confusing. It's not like so what are the two answers here? What does X equal on the left? And what about and also on the right?
6.
6, and then the one on the left here,
17.
17. Yeah, and it's okay to have it sort of written this way where the numbers on the left, variables on the right, but I usually reverse it so that you get this way, where the variables on the left. So the starting point to all this is like seeing the operation and knowing how to undo it. So let me just throw a few more here. Let's say like 7x equals 28. How do you solve something like this?
You would divide it.
Okay, divide both sides by 7.
I just was confused about keeping the lines sorted up where everything goes and which one of them you wrote
You can
underneath or not.
Yeah, you can organize it the way you kind of however you see fit. I mean, you see me drawing a lot of lines to just show some separation. How about let's look at this here. How about x plus 7 equals 21?
Subtraction.
Okay, subtract 7 from both sides. What does x become?
Hmm. 14.
14. Good. Okay, so let's go back to two-step equations. I'm pulling up one of my worksheets that I think could help here. There's only a couple of possibilities, and like even though it seems like there's a lot of um, different types of two-step equations, there's actually only 4. So I divided them into types here. So all the problems we're going to look at next, we're going to add and then divide. Okay, and your focus is on the side with the variable. Okay, 4x minus 5. So you look at that side and you're going to add. Now you add the number that's being subtracted, not the number in front. It's the number that's being subtracted. So you're going to add 5, add
But
5.
do you bring down the 4x at all?
Yes, yes, you bring it down. And what about on the right?
You do the same thing.
So it equals 8. And then now you divide. You divide by the number in front of x. So you divide both sides by 4. So here is a problem for you to look at. Let me put it right here. It's exactly the same. You solve by adding and then dividing. Do you want to give that a shot, please? So hopefully you're adding 6 to both sides and bringing that 8x down like you were asking about. That's $32 on the right. So divide by 8, divide by 8. Can I give you one to try?
I got 8 equals 4. I forgot how you divide. I forgot the 8 would be left for some reason. X 4.
It's okay. let's try another one here. You're going to add and then divide.
It
Add
just
and then
takes me
divide.
a second because I double check it a couple times on the calculator when I'm writing
Yeah,
it out.
that's good.
Is it frozen?
Nope, just waiting for you. Just want to see if recommend you trying this one. It's just like the last ones. I can scroll up if you need me to show you the work, but
Oh,
it's
never mind.
exactly the same.
I was zoomed in. I didn't see the
Oh,
problem.
sorry. We got to get a little lower there.
Is it x equals 6?
Here's x equals 6. Very good. Okay, let's do, I think we got time for one more here. Let's try, let's try this one here. So just a little bit different. I'll step you through this one. So sometimes the order is a little different. Like this is minus 18 plus 7x, but you undo a negative with a positive. So you add 18 to both sides like this. And then you bring down the 7x equals 49. And then you divide both sides by 7. So x equals 7. Let's look at another one here. So you always look at the side with the variable. So this time, again, like you undo you look at the side with the variable, you got -4 plus 5x. You undo the -4 with a +4. You bring down the variable, so that's 5x. On the right, -19 plus 4 is -15. And then you divide both sides by 5. So x equals -3. So you could have positive, could have negative answers. Okay.
So no matter what order they're in, the only ones you change are the ones that don't have the variable.
Yes. Yes.
And then if it comes to 0, you bring the variable down.
Yes. Yes. Now there's 4 types. We only got through 1 type, so there's like 3 more of these. So I would recommend for next time that we do that.